Okay, some of you will be pleased to know that we're moving back to pure maths. We're going to do some work on surds and indices, and then we'll be moving into differentiation from there. So let's start with surds. Some of this will be revision for some of you. So surds is basically square roots, and the rules you can use are root A times root A is A. That's kind of definition of what square root is. If you've got the square root of A times B, that's equal to root A times root B, and the square root of A over B is equal to root A over root B. The thing you mustn't do is split a square root across an addition. That is really bad maths. So the square root of A plus B does not equal root A plus root B. You just need to square that to convince yourself of that, and you will not get A plus B. So please be careful of doing that. It's a real rookie error, that one. So simplify. We've done simplifying surds, but just to remind you, square root of 72. So you're looking for the biggest square number that goes into 72. So square numbers: 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, etc. So the biggest square that divides into 72 is 36. So that's square root of 2 times 36. And then we can split that root. And root 36 is 6. Root 2. Moving on from there, if we've got something like 3 root 5 squared, that's equal to 3 root 5 times 3 root 5. And multiplication is commutative. So that's the same as having 3 times root 5 times root 5. 3 times 3 is 9, root 5 times root 5 is 5, and 9 times 5 is 45. And then multiplying out brackets, you just multiply them out like a quadratic. So surds kind of have a real part. They have they have two parts. So a surd would be written as A plus B root C. So you have a section that isn't a square root and a bit that contains a square root. So these are examples of surds. So 8 times 2 is 16. 8 minus 8 root 5 plus 2 root 5. And then root 5 times minus root 5 is minus 5. And then collecting all of that up, so we've got 16 minus 5, so that's the section without a square root in it. And then minus 8 plus 2 root 5 is minus 6 root 5, just tidying that up. So if you could start by doing the show that sheet, and then once you've done that, move on to page 24, question 11, question 12. And if you want to, then you can go on to some of the extension questions. But start with the show that sheet. It's quite a nice sort of introduction to surds. I was just looking at it. If there's any big surds in there, I don't think there is actually for this one, but it's quite good sometimes to simplify down surds. So like question 4 on the show that sheet, I would think about simplifying down the root 18 and the root 50, and then you can get things to multiply together. So yeah, if anything, you want to think about simplifying surds down. And it's almost like having things in prime factors, and then you can look at which surds fit together and which don't.